Okay, this is part 3 of my refutation of Sam Geppi's presentation on KRS channel against the use of the tropical zodiac with sidereal nakshatras. In part 1, I answered his appeal to tradition argument by stating that tradition is not accepted, even in Indian tradition itself, as an ideal way of determining the validity of anything. Tradition can often be wrong and even out of touch with its own root concepts. In part 2, I dealt with Sam's claim that the stability of Indian astrological culture over the millennia proves or shows that the sidereal zodiac is more stable and that Indian astrology is just superior and more accurate. So my answer to his first claim is that the sidereal and tropical zodiacs are equally stable. Their instability is only in relationship to one another. And finally, I explained that the real reason why Indian astrological culture has been so stable over the millennia is that Indian culture as a whole has been so stable over the millennia, especially when compared to the upheavals in religious and social culture that went on in Europe and Arabia. So now, here in part 3, I'll deal with Sam's claim that the more accurate way to measure a planet's position in space is to just reference it observationally to a star. This proposition is just incorrect. It's simply much more accurate to measure things mathematically than it is to do it by eye. In fact, this is why any siddhanta, any astronomical system, any modern software, they always use tropical calculations. Why do you think you have to know the person's latitude when you enter the birth chart information? If you don't have these tropical references to latitude and the equinox, then you cannot determine with accuracy where the ascendant is. And if you cannot determine with accuracy where the ascendant is, you cannot construct a horoscope. So without tropical calculations, it's impossible to construct a horoscope. Sidereal objects are found, measured, located, simply by subtracting the ainamsha from the tropical coordinates. The calculations are tropical, and then to find the sidereal object, you just subtract the ainamsha, which measures the discrepancy between sidereal phenomenon and tropical phenomenon. Now, Sam made another sort of interesting claim because it's made so often by so many people, which is that the sidereal zodiac is observationally verifiable. You can look out and you can see that the moon is in that constellation, just like your software tells you. Right. This claim, again, is just incorrect, and you wonder, how do people make these claims? Don't they try it themselves? If you try it yourself more than a dozen times, or more than a few times, you'll notice that you'll have correspondence, rough correspondence, between the sidereal zodiac and what you observe with your eyes, but often you won't. So, to explain this though, let me show it to you. Okay. So here is what you would see if you were outside my door yesterday afternoon and had super special sunlight-proof glasses. And you could see in the sky, all you can really see is dots of light. But we connect these dots of light. So here we have the most widely accepted connections of the stars. Now, if you look through these constellations, you'll find ones that bear the names of the zodiac signs. And if you trace all of them, you'll find the ecliptical area. The ecliptic is the part of the sky through which the sun appears to travel. And the planets basically following the sun on the same path. Now, if you draw the borders of the zodiac constellations in terms of where they fall on the ecliptic path, then you'll notice right away that they are dramatically unequal in size. Here in this image, you can see the inequality that's going on with Virgo and Libra and Scorpio, there's a lot of inequality in size. There's a similar thing that goes on between Pisces and Aries and Taurus. So here you can see that this is not the sidereal zodiac. The actual constellations themselves are of varying sizes, but the sidereal zodiac is of equal sizes. Every division is of equal size, so it can't be identical to the constellations. Now here's something really interesting. Look closely and you'll see that in this image you can see Spica, which is a very important star. This star, Spica, is the Yogatar, the primary star of the Chitra Nakshatra. And so according to the Chitra Paksha Ayanansha, this star, Spica, has to be, by definition, is at the very end of Virgo and the very beginning of Libra. But look where it actually is in terms of constellations. If you look up with your eye to verify your sidereal zodiac, you'll find out that the anchor point of your sidereal zodiac isn't where it's supposed to be. It's not at the end of Virgo, it's about 2/3 of the way into Virgo, demonstrating once again that the sidereal zodiac is not exactly the constellational zodiac. So what this is showing you is that the sidereal signs are not observationally verifiable. They're also theoretical constructs, okay? And the constellations are approximations of them. So this is what a sidereal zodiac looks like. You see the Virgo-Libra border falls right on Spica. That's the defining characteristic of it. But now you see there's another problem that's going to come up, demonstrating once again that this is not the observational zodiac. The sidereal zodiac is not observational. What's going to happen when Jupiter goes on the other side, passes Spica and gets to the other side? It should be in Libra. And your software set to the sidereal zodiac will say, okay, Jupiter has moved into Libra. When you look up with your eye, you're going to find Jupiter on Virgin's leg, on the Virgo's leg, not in Libra. So this is just kind of elaborately demonstrating that it's false to claim that the sidereal zodiac is A, identical to the constellations, and B, observationally valid and verifiable. Now here's an interesting thing. This software that I'm using to generate these images of the sky is a planetarium software called Stellarium. If you click on Jupiter, it tells you a lot of facts about it. And look what it says for Jupiter's coordinates. It says Jupiter's at 203 degrees. So 203 degrees, it's right in front of Spica. Spica is supposed to be at 180 degrees, right? It's supposed to be the border of Libra, which begins the 180 degrees. So Jupiter should be at 179 degrees. Why is this planetarium software saying Jupiter is at 203? Because this planetarium software is reporting to you the tropical coordinate. So let's take a moment to understand where this tropical coordinate comes from. Tropical coordinates are different from sidereal coordinates because the tropical zodiac is not anchored to a star. Okay? That's the first thing to understand. It's not anchored to a star. Now let me explain what it is anchored to. Let's keep looking at this same area of sky and let's find the anchor point, tropically speaking, for the Virgo-Libra border. The way that you start to find it is first map the Earth's equator. What that does is divides the heavens into an upper and lower portion, Uttara and Dakshina. This is not a hemisphere-specific judgment. Up, Uttara, means closer to the top of the universe, which is Dhruva, Vaikuntha. Dhruva Vaikuntha is the northernmost point. North means up. So the part of the sky that's above the equator is called the northern part of the sky or the upper part of the sky. Not because it looks that way from the north, but because it's that way in relation to the Dhruva, the northernmost point of the heavens. And conversely, the lower portion of the sky is called lower or southern because it's further away from Dhruva Vaikuntha. So now that you have the equator mapped out into the space, now trace that ecliptic point again. This is the path of the sun, which is also the path of the planets. So now you can see that the sun and the planets, they spend about half of their orbit in one portion and half of their orbit in the other portion. So this is where you get the idea that the sun comes up and down, not in relation to your location on Earth, but in relation to Dhruva, the universe's highest point. When the sun moves up, it's called Uttarayana, and when the sun starts moving down, it's called Dakshinayana. Now you notice there's points where the sun crosses and straddles these two hemispheres and crosses from one to the next. Those are very, very important points in the sun's orbit. These points signify the celestial rising and setting of the sun. When the sun moves up into the upper portion, it's the celestial sunrise. And when the sun moves down into the lower portion, it's the celestial sunset. So here, we're looking at the celestial sunset, because on this side, over here by Virgo, it's where the sun is headed downwards on this Dakshinayana path. These points are also called equinox points. The reason why it's called an equinox is because the days and nights will be of equal length when the sun is at this position, because the sun is equally in the northern and the southern hemisphere. The more the sun is in the northern portion of the heavens, the more the northern hemisphere of the earth is favored with light. And the more the sun is in the southern hemisphere of the heavens, the more the southern hemisphere of the earth is favored with light. So you have longer days in the south when the sun is in the south, when you have longer days in the north when the sun is in the north. And this is how you measure the sun's position, by the shadows, the length of shadows, and the length of days and nights. So now this particular point here, where the sun sets, celestially speaking, the descending equinox, this point is the anchor point of the Virgo-Libra border in the tropical system. And then all the other signs simply fall into place around it. And by falling into place, they will also line up with these three other key points: the ascending equinox, the highest ascension point, and the lowest ascension point. So that's why this software is reporting Jupiter at being at 203 degrees. That means it's 203 degrees away from the ascending equinoctial point, which means that it's 23 degrees past the 180 degree mark, or it's 23 degrees into Libra. And that's exactly what your software will report if you set it to use the tropical rashis. Now the question will arise, why is there such a displacement between sidereal and tropical signs? So let's go back in time, and I'll explore this more when I explore the historical argument. But back in time to when the advances in mathematics allowed astrologers to use these 12 divisions of the sun's path really widely for every planet. And they could know the locations of every planet all the time, even when you couldn't see them. When they started to use these 12 divisions, they correlated them to the stars. Because for centuries previous to that, every single thing that they had done astrologically was in reference to stars. At the time that this happened, at the time that this correlation became standardized, the descending equinox coincided with Spica. And that's why they said, okay, the border between Virgo and Libra is equal to the position of Spica. Now, the sidereal theory in modern astrology is that the border of Virgo or Libra should always be anchored to Spica, even though the very reason why the border was put there in the first place was because that's where the descending equinox was. They say even though Spica will drift away from the descending equinox, still the border of Virgo Libra must follow it. That's the sidereal theory. So you wind up with this, which is really a snapshot of the signs from the time they were first standardized, which is roughly 2,000 years ago. On the other hand, the tropical theory is that, well, the reason why Spica was associated with Virgo Libra is because that's where the descending equinox was. The border of Virgo and Libra is defined by the descending equinox. The border of Pisces Aries is defined by the ascending equinox. Therefore, if the stars move in reference to the equinox points, the borders of the rashis shouldn't move with them. They should remain anchored to the equinox points. Now you can already see why this is more rational, but in the upcoming episodes of this series of videos, I'll explain it in more detail. So please stay tuned.